This unit, we're actually going to talk about power. And power is the third concept here. We've already talked about work and energy. And actually, once you understand work and energy, power is actually the easiest of the three. So whereas work is the change in energy, power is actually something a little more subtle. Power is change in energy with respect to time. And we can say that change in energy over time. So what does that mean? Well, if we do 10 joules of work, so work is 10 joules, that means energy increases by 10 joules. Now let's say it takes us 10 seconds to do this, and that our energy is done over a continuous amount of time. So we don't do it all at once. We do 1 joule per second. So we have 10 joules per 10 seconds. As we said before, 1 joule per second. And that unit is called 1 watt. And actually, a watt is one of the physics units you might have seen before. If you've ever changed a light bulb, you might have noticed that common light bulbs are 75 watt or 60 watt or 100 watt light bulbs. And a 60 watt light bulb produces 60 watts of light, and that's 60 joules of light per second. 75 watt light bulb is brighter, it outputs more power, and a 100 watt light bulb is the brightest. And these light bulbs are actually going out of production very, very soon. We're replacing them with different light bulbs that have a different rating system. But with these, this is the rating system. It's actually very simple to understand. It's a common physics concept. So now how do we talk about this kind of power? Well, let's take an example. If someone's working on a rowing machine, and they're pulling on the handle of the rowing, and let's assume they're pretty big, so they're able to pull the handle of the rowing machine 2 meters forward and back. And let's say it's a pretty stiff rowing machine. It takes 50 newtons of force to pull the handle back. That actually wouldn't be all that stiff. That's only the same as pulling out 5 kilograms, so 10 pounds, but still a reasonable workout. So they do 1 stroke per 2 seconds. How much power are they outputting? So let's try to calculate this. And let's assume it takes them no time to go back again. So it takes them 2 seconds to go forward, but no time to go back. So let's see. Let's start with how much work are they doing per stroke? They're exerting 50 newtons of force times 2 meters, because energy is measured in Newton meters. That's 100 joules. And they're doing it over the course of 2 seconds. So we can say that's 50 watts. And that's a reasonable amount of energy, but not a ton. That's enough that if a light bulb was connected to the rowing machine, they'd be able to light up a small light bulb. Wouldn't be anything huge, but a little one would light up. So now to provide some context, let's introduce another unit. And this is actually a really old unit, but also one you might have seen. And this unit is horsepower. And horsepower is, you guessed it, unit for power. It actually is the word in its name. And 1 horsepower is approximately equal to 745 watts. And this is one of the more interesting physics experiments. Actually, the way they discovered this is they took a big hole and put a big weight in it. And they made a horse pull up the weight using a pulley. And the horse was able to exert a certain amount of force across a certain distance. We might not know the exact ratio, but maybe the horse was able to go 7 meters per second, pulling with 100 newtons of force. And then what that would say is 7 meters times 100 newtons would be 700 newton meters, 700 joules, divided by 1 second. Newton meters per second equals watts. So that'd be 700 watts. So that'd be slightly lower than horsepower. And they actually tested this. So when an engine is rated as having a certain number of horsepower, it means it can output that much power. However many horsepower times 745 watts. Now going back to our previous example of the rower is only doing 50 watts, exerting 50 watts of power. So he's doing significantly less than a horsepower. He's actually doing about 1/14. So he'd have to pull with like 745 newtons of force across a 2 meter distance every 2 seconds in order to do 1 horsepower of work. Now, horsepower isn't the most modern of units. You'll almost never see it in an actual calculation, but it's just kind of interesting to see how that evolved over time and how our understanding developed. So hopefully now you understand energy and power and work, and you're ready to move on to some practice problems.